In section 6.8, we learned how to calculate an empirical formula. And the empirical formula gives the lowest ratio of atoms of each element. I don't think I really gave you an example of that, so let's just throw something in here. So hydrogen peroxide has the formula H2O2. If you experimentally determine the formula of hydrogen peroxide, you're going to come up with HO, because that's the lowest ratio. It's a 1-to-1 ratio. That's the empirical formula. The molecular formula, though, is the number of atoms of each element actually in one molecule. If you were able to examine hydrogen peroxide molecules, they are not one hydrogen and one oxygen. They're two hydrogens and two oxygens bonded together. This is the molecular formula. It is a multiple of the empirical formula. Now sometimes, like if we, let's see, some space over here. If we have water, different compound, the molecular formula for water is H2O. The empirical formula for water is the same. It's H2O because it's already in the lowest ratio of 2-to-1. So here the molecular formula is twice as big as the empirical formula. So it's always a whole number multiple. We just need to find out what that number is. So for an example here, if the molecular formula was CH2O, to find the molecular formula, we're just going to have to multiply it by some number, n. How do we figure that out? Well, we take the mass of the actual molecule and divide it by the mass of the empirical formula. And when we divide those, we should come up with a whole number, and that's the number we multiply by. So that probably didn't make a lot of sense. Let's do an example. Here we have a compound containing phosphorus and oxygen. It has a molar mass of 219.9 grams per mole and an empirical formula of P2O3. This piece of information would be obtained using perhaps a mass spectrometer or some other method of analysis that's beyond the scope of this class. But that would be determined separately from doing something like we had the example of the water, where the water was electrolyzed and you form hydrogen and oxygen, and you can weigh them and find the ratios and get the empirical formula. Getting the molar mass is obtained separately. So here we've got P2O3 is the molecular formula, the empirical formula, and we know that the empirical formula is some number n times that. Well, what is the molar mass of this empirical formula? The P2O3. No, that's the molecular formula, which we don't know. P2O3 would be 2 times the mass of phosphorus plus 3 times the mass of oxygen. And if I remember correctly, that's 109 point something. I have to get out my calculator. 2 times 30.97 plus 3 times 109.94. 1 mole of the empirical formula weighs 109 grams. 1 mole of the molecular formula weighs more than that. So we have to figure out how much more, what factor. So we take the molar mass of the, where am I going to do this? I'm writing too big today. We take the actual molar mass and divide by the mass of our empirical formula to find out how many times bigger is the molecular formula. So 219.9 divided by 109.94. 2.00018, and it keeps going on. That's really close to 2, isn't it? These numbers are not going to come out exactly because this is from an experiment and there's always some error. but that is definitely close enough that we can round that to 2. So we're going to call that 2. So that tells us that the actual formula contains 2 empirical formulas. So we just multiply the subscripts by 2 and we end up with P4O6. And that is the actual molecular formula. A molecule of this compound has 4 atoms of phosphorus and 6 atoms of oxygen. But the lowest ratio is 2 to 3. The empirical formula determination always gives us the lowest ratio. Any questions? And that's the end of the chapter. So there's the review slides.